Welcome back, guys, and happy to be here again. I was busy with my private life, so okay. Today we will talk about the building of fuselage, and before start, I would like to tell you some historic facts. In the beginning, there were the two types, the Pratt and the Warren. The Pratt was the first, and it can be recognized by a straight angle structure, and this was the first one. Then came the Warren, which does not have 90 straight angles but just all diagonals. So in this case the strength of the structure and is increases. So this is the second one, and of course this can be made of wood or of steel. It's not a problem. Then with the increasing demand of power and speed comes watch uh, the type we know in these days, and this is called the semi-monocoque and monocoque. Coque, not what you think, means in French mean shell. So in this case the shell absorb all the loads and enhance the rigid the behavior of the structure from from wind or some maneuvers that the airplane can undergo. The enhancement of the monocoque fuselage was the semi-monocoque, which adds the stringer, the bulkhead, the skin, and former or ribs, or what you want. I mean, it's just about names. Important is the function. Monocoque is also used in car industry. For example, this is a Lamborghini. It's a monocoque, which means it's a single shell. This is a single part, but just for info this part. In a fuselage we have three important parts, which are stringers, longerons, and in some case the keelson. This longeron 4 is not the real number, it's just to show that in a fuselage the borders must be reinforced with some kind of structure that have better mechanical properties than stringer, and also are bigger than the stringer. So if you choose balsa, you can use beech or pine for longerons. Also the type, because you can have round or squared, so it's up to you depending on the type of wing. You have to set your fuselage, because as you can see the former or ribs are strongly influenced by the type of spar you choose. So in this case, in this one substantially there are not so many difference, but in this case your fuselage will be um, should be made in order to guarantee the converging spars, or instead you in the end you can use this one, but it's up to you. I mean, I'm just showing you. Okay, now we see some kind of type of fuselage. For example, in this case it's a very simple low speed airplane. So we have 1, 2, 3, 4 formers. These are the longerons and these are the stringer. In particular consideration should be made on the tail, because as you can see this is one type of tail attack, empennage, sorry, not tail, empennage. So in this case the former should be should have the same angle as the empennage. So if you are building something like this angle should be the same as this one. So and then you have your formers. In this case we have a higher speed, so we have more formers, few longerons, and let's see another one. For example, in a high-speed jet we have a lot of stringers, and we have these rings that enhance the rigid behavior, and then we have another low speed airplane also here. For example, in this case we can see that in the where the wings are attached we have an increasing of stringer, so this enhances the mechanic behavior of the wings in case of turbulence or hard angle or banking maneuvers. Let's take just this case. We can see that the former can have two type of tractor. The one is okay, can be round, so no, sorry, we can have a round former, and at this point we can for the stringer we can do two different approaches. We can have two different approaches. The first one is to build holes inside and then pass the stringer on this hole. The second type is to build squared box and then trimming this part in this way, and then you will have your stringer here. Okay, this approach is the best for RC plane, because if you use the first one, let's say that this is your former, and you made a hole here and here, which corresponds one hole here and one here. Then you have another former here. Okay, so if you choose this configuration, pay attention to this distance, because if this the spacing between two formers are big, you will have your stringer here, and then you cover, which can be or a cover or mylar here, and this part. This is empty space. So when you're traveling at high speed for a RC plane means, let's say, 100 kilometers. You will have a bubble here and here, and at the end of all, the mylar or the cover will be detached. So for our purpose, the best is to use this approach, which is what we see later. So in this case, you will have your former in this way. Oops, sorry. And in this way. So when you will apply the mylar, twill, or any kind of other, or a cover or what else, will be just glued to the stringer or longer on, so it cannot be you will not have some bubbles or what else. Okay, so this is what we will try to build today, which is substantially the tail of the wing of the fuselage, because the fuselage is just a cylinder, so it's a copy and paste of the bulkhead. Well, to do this, we have to use some consideration with the trigonometric functions, and this is let me add another one here, this one, and we will hide this. Okay, well, we have the bulkhead, and we have the last former. We have an angle here. This angle most of time varies from 10 to 5 to 15 degrees, but depends on the lift coefficient, because during takeoff this part should be parallel to the ground, in this case, in this way. Yeah, well, it's okay. I mean, this is an airplane taking off. So between the bulkhead and the last former, we have several formers that depends on you. I mean, it's not you can put one one here in the middle, or you can put 100. It's up to you. we need to calculate the diameter of the former in order to achieve our angle. So the formula is the following. Let's open this one. Okay, this is D. This is the radius 1, radius 2, radius n, and RB. Okay, RB is 100 millimeters. R1 is I'm writing too big. R1 is RB minus D multiplied by the tangent of the angle divided by 2. So if we use RB 100, R1 is 89.37. Then R2 will be 89.37 minus the tangent alpha 2, and this is 78.744. In general form will be so R2 should be R1. Sorry, this calculation are valid for alpha equals to 12 degrees. After you have repeat all of these values, then you have to build all your formers, which I draw in a single place, in a single part, and not just in a nine in an assembly, because all this part is made by the same material, and also we save resources when we make an assembly. So what you have to do first of all is to build your bulkhead, which in this case is 100 of the radius, and then you have to build all the slots for stringer and longerons. Since this is a circular pattern, you can use circular sketch pattern in this way. I will show you one, and then you can see, you can apply this for the all parts. Just consider that when you are reducing the diameter of this former, the slots should not change, otherwise you will have a stringer which you cannot build, because it starts from 5 millimeters, and then you have to grind in order to reduce the volume. You can do it, I mean, it's up to you. For example, this is 5 millimeters, and the other is 5, and this is the last former. So if you check this one is 5 and oh, 4.97. Okay, we will put 5. Okay, 5. So in this case we will maintain the same geometry of on all parts. And the longerons are 10 millimeters tall and 10 millimeters width. So after you, yeah, I discard it because this part is made is 5 millimeters, is 10 millimeters, so it's not a problem. Okay, so once we have our all parts, we can see that I added different planes depending on the number of pieces, and the distance between them is 10 millimeters. So in the end we have 60 centimeters. Oh no, see, yeah, 60, which is too long, but it's not a problem. You can reduce it. If you reduce the distance, you need to modify D, because D is 100 millimeters, but if you use 50 or less, or you have to put the value in this formula. So this will look like R1 is alpha, oh sorry, divided by 2. But if you use 50, this will look like 50. Okay, so this just to make sure that your calculations are going good. Well, just a trick when you are building your tail. The first thing you have to do is not move the sketch, but the first thing you have to do is to build the former in the right geometry, and then in the end you move it upwards. How to move it? Well, it is easy. I mean, you come here, you edit the sketch. As you can see, there is a difference between the center and the center of the drawing and the center of the sketch. This is the spacing. The difference, how how much do I have to move this part in order to make this channel? Well, this can be achieved from this formula, because if you use if we use R1 is 100 multiplied by 100 tangent 2 divided by the angle, angle and divided by 2. This will give 89.3722. the difference between this value, the radius, and 89.3722 corresponds to the height, to the difference between this point and this point. I will show you. We can do. I will show you this one. Let's see. If we add this distance to 89.74 gives 100. The second former, following the same calculation, have which means the difference between where is it? Okay, the difference between 100 and this distance, and it will give 100 more or less. So yeah, okay. So if you repeat the same procedure for all former, you will have, in the end, you will have a structure like this, which have 12 degrees of angle. So if I was not so clear, please watch again, because I can YouTube times are shorter than our mind time. So I will just resume quickly. First, we have to set the distance between ribs. Second, diameter, no, sorry, the radius. The formula is not diameter but is radius. Okay. The radius of the former or rib is the same. With wing are called ribs, with fuselage are called former. Then choose your angle, which depends on the lift coefficient. Then you know that the radius of former 1, it's the radius of the former 0 minus tangent of alpha divided by 2. R2 is R1 divided by 2. This formula gives the radius of the former. But if I have former 1 here, I have the former 2 here, but they are aligned, so this distance is 100 minus the radius given. Yes, this is for former 2. So we need to raise our former in order to make coincident the upper part in order to have our angle. So if we repeat all this part of this procedure for all the formers, we can have achieved this structure.